welcome to another math tutorial. In this video, we're going to continue with our exploration of the chain rule for derivatives in calculus, and we're going to look at what I like to call the power chain rule. In other words, we're going to be using power rule to take the derivatives, but we're going to have functions within the power so that we're going to have to run a chain rule on it. So I just simply call this power chain rule. So I've got a few examples to walk us through this. And with that said, let's take a look at the first one. Okay, this first example, we're asked to find the derivative of y equals the quantity 3x plus 1 squared. And we're going to do this with chain rule. We're going to use our new rule for the derivative of this function. Now the first thing that I notice when I look at this, and I know that I want to use chain rule on this, is I've got this set of parentheses. The parentheses are sometimes helpful for me. The parentheses are showing me what is on the inside and what is on the outside. Okay? And when I use chain rule, I have to make sure that I differentiate the outside part first. So it's important to understand here that the outside part of this function is just simply a power. And so what I'm going to do is I'm going to use power rule on this outside part first before I get to the inside part. So here's what that's going to look like. Let's go ahead and do this here. So I've got this y function, my y prime is going to be first. So first I'm going to deal with the power. And so how do we do a power, right? We should be familiar with this. We're going to bring the power out in front, and then we're going to drop the power by 1. So it's going to be 2. And then when we do that, we keep the inside part the same. So this 3x plus 1 is just going to stay 3x plus 1. And we drop that power 1 to the first power. So that's the power rule. That's the outside part taken care of. Now I need to multiply that by the derivative of the inside part. Okay, so my inside part's derivative is going to go here. So the derivative of 3x plus 1 is just simply 3. From here, the calculus is done, right? We've done the derivative, that's complete. Now we're going to proceed to just some algebra to clean this up. And so cleaning this up, I'm going to take the 3 and the 2, I'm going to multiply those to give 6. I've got this quantity 3x plus 1. That's a first power. I can just drop that. I can leave this as it is if you want it in a factored form. If you don't want it in a factored form, you can of course distribute the 6 and get 18x plus 6. Either of these answers would be acceptable and just fine. Okay, our next example, y equals the quantity x squared plus 5 raised to the 6th power. Looks very similar to the last example. You might have looked at the last example and thought to yourself, yeah, I could just FOIL the 3x plus 1 quantity by itself and then just take the derivative. And we certainly could do that. We could have skipped chain rule completely and just done the derivative the way we knew how to do. I showed you that just to kind of warm us up to problems like this, because this now, the exponent, the power on the outside is large enough that I don't want to take x squared plus 5 times itself 6 times, right? I don't want to do that algebra. I don't want to do that binomial expansion at all. That would be a lot of work. So instead, we're just going to run a chain rule on this. And again, when I look at this, I see that I've got this inside piece, and then we've got this power that's on the outside. So when I do this power chain rule again, we're going to start with the outside first, and then we'll take the derivative of the inside after we've cleaned that up. So here we go. Y prime, the power is 6 power, so 6 to the front. 6. We're going to keep the x squared plus 5 as it is. We're going to drop that 6 power down to the 5th power. Okay, so that's the power part. Now we're going to chain this by multiplying by the derivative of the inner part. So x squared's derivative is 2x. Of course, positive 5 as a constant's derivative is 0. So the derivative of the inside is just 2x. I can do a little bit of algebra just to clean this up. I'm going to multiply these together. So my derivative y prime is equal to 12x times the quantity x squared plus 5 to the 5th power. And that's good enough. You definitely do not want to make the mistake of distributing that 12x inside, because the power would have to come first. And there's certainly no reason to expand that binomial to the 5th power. So we're just going to leave it exactly like that. Okay, the final example problem, we have y equals sine squared x. I think for me, when I'm taking derivatives of trig functions that are raised to powers, the first thing I want to do is rewrite the function. I'm going to rewrite or re-express the exponent. So I'm going to rewrite this. Notice it's still y. I don't have y prime yet. And I'm going to say this is sine x squared. So these are different forms, but they're the exact same meaning. They're the exact same expression. Now, when I write it like that, it's much more clear to me, and I think anybody looking at this, that the sine is the inner function and the power 2 is the outer function. Whereas when you look at it here, the placement of the power here almost looks like it's inside that sine function, right? Because you go to the middle here and you see that power, and you would misinterpret the function if we did it like that. So seeing it this way, I know I'm going to run a power chain rule on this. My derivative starts with the power, so 2 comes to the front. I have 2 times sine x to the 1st power. Again, every single time you do the power part, right, the outer derivative, you do not touch the inside. That inner part is still sine x. Now we're going to run the derivative of the inner part. So the derivative of sine x becomes cosine x. We multiply those together. I do any sort of algebraic cleanup that I can do, and there's really nothing I can do here except maybe get rid of the power 1 and drop these parentheses. So I would make this 2 sine x cosine x. Okay, that's it for my video on power chain rule. If you have any comments or questions, please feel free to leave them down below. If you thought this video was helpful in any way, please give it a like, a thumbs up to help support the channel. I appreciate it, and I'll see you in the next one.